Hi, I've just spent the last 2 hours annotating the IB Physics data booklet. I've never done it before and oh my gosh, I cannot believe how useful it is. I actually think this is a key task that you should all undertake in the weeks preceding any exam. To do it properly and to make it useful, I have some tips to make sure you maximise the effectiveness of this. Honestly, it's a game changer. Okay, here we go. Tip number 1 is to add diagrams to aid memory. Let's jump down to mathematical equations. One of the key relationships that's used inside IB Physics is the inverse square law. And equations using the inverse square law are dotted throughout this data booklet. However, adding the diagram of the inverse square law and linking it to intensity, electric field strength, and gravitational field strength on this page help you understand the concept of inverse square law. It's so easy to add diagrams in almost every topic in IB Physics. Let's jump down to Doppler effect. In this data booklet, you're given these 2 equations for Doppler effect in the additional higher level, but they don't really mean anything to me. However, as soon as I see the diagrams of the Doppler effect, it's much easier for me to relate the formula to the actual situation. We can keep going. If you look in fields, it's much easier for me to relate the equation in electric field strength in a uniform field when I see that uniform field beside it. Similarly, if I'm thinking about motion in electromagnetic fields, I want to see these diagrams of the Fleming's left-hand rule and how to find the direction of magnetic field strength when you're looking through current in a long straight wire. These diagrams help me work out what the formula is relating to, and they bring everything back to my memory. So tip number 1, add little diagrams where possible. We're going to stay on this page for tip number 2. Can you see down here, I have a formula that's in a red box. That formula is not in the data booklet, but it's really useful. That formula tells me how to find the radius of a moving charge inside a magnetic field. And actually questions like that in the exam quite often give you 3 marks, 3 genuinely really useful marks. And I want to memorise that formula. Now, if you're wondering what formula are not in the data booklet and you have to add them, then of course, GradePod's here to help. I have done a blog post for you that tells you all the formula you must memorise to ace your exam. Otherwise, you can access this annotated data booklet when you join Tribe Physics. So tip number 2 is add formulae that are not in the data booklet. Tip number 3 is head to the fundamental constants page and highlight the following constants to memorise. I know they're on the data booklet and you think, why would I memorise them? Trust me, this will speed your exam up so much. So the constants I would memorise are the acceleration of freefall g, and we're memorising that as 9.8 metres per second squared. Little tip, if you're doing the multiple choice questions in paper 1A, you can just use 10. The answers will work if you use 10 in paper 1A. The second constant to remember is the gravitational constant, Newton's gravitational constant. You don't need to remember all the units, but I would remember 6.67 times 10 to the minus 11. Another one I would memorise is the Coulomb constant. The Coulomb constant is 8.99 times 10 to the 9. Again, don't memorise all this stuff, the units, just memorise the number. And remember, of course, that K is actually equal to 1 over 4 pi epsilon naught. So that's where these 2 constants interlink. An easy one to memorise is 3 times 10 to the 8 metres per second for the speed of light. And finally, I wouldn't memorise the elementary charge, even though it's the same number. I would memorise it as 1 electron volt is equal to 1.6 times 10 to the minus 19 joules. So do by all means memorise that number, but remember it as 1 electron volt is equal to that. Trust me, that will just speed everything up. Tip number 4 is key, and it's the most important tip for this data booklet, adding annotated graphs to highlight relationships. You can see it all over the data booklet, and I'm about to show you in a second. But we'll start with the electric symbols. Head to the electric circuit symbols, and this page is usually overlooked. But if you add the graphs that relate to each of these symbols, beside the symbols, it begins to add so much more depth to your understanding of the data booklet. So what do I mean? Well, if we look at a fixed resistor here, the IV characteristic graph for a fixed resistor at a constant temperature is a nice straight line through the origin. So that tells us it's an ohmic conductor and R equals V over I. If we think about a thermistor, we know that the resistance of a thermistor changes with temperature. But actually adding this graph shows us that as the temperature increases, the resistance decreases. It's an inverse relationship. One more, let's have a look at the lamp. We know that the IV characteristics of the lamp is non-ohmic because it's not a straight line through the origin. Every single topic in IB physics has a useful graph that can be annotated to help you. Let's look at impulse. Impulse is the area under a force time graph. So if you draw the force time graph, draw how a force changes over time, and this could be a racket hitting a ball, showing average force, and the area under the force time graph gives impulse. That's so useful. Let's head down to work, energy and power. The area under a force distance graph is equal to elastic energy. I mean, I'm sure there's a zillion more. Let's keep going. Okay, this graph here in special relativity shows how the Lorentz factor changes with speed and how it increases dramatically close to the speed of light. Let's look for more graphs. Oh, the thermal energy transfers graph. Oh, another great graph. Oh, there's so many good graphs. The intensity graph for Wien's law shows how the maximum wavelength of intensity of radiation is related to temperature. The gas laws. I cannot tell you how useful adding graphs to your data booklet is. This one is so key as well. If you're looking at internal resistance, then this voltage current graph gives so much information. The intercept is equal to the EMF and the gradient is equal to R. These graphs are key, and I can't believe I left this tip to tip number 4. It should have been number 1. Tip number 5 is really simple, but it's sometimes you just need a little reminder what the equations are actually used for. So for example, in C3 wave phenomena, I need a little reminder that this equation is only for single slit diffraction. And this equation is only for diffraction gratings. And these equations in Doppler effect are only for sound. Let's see where else I've put that down. Oh yeah, this equation for radial fields only. This equation here is potential energy. This equation is potential. Sometimes you just need a little couple of words just to remind you, okay, I know we're on gravitational fields, but this is what the concept is related to in gravitational fields. So tip number 5 is just to put a few words clarifying what concepts each equation is for. My final tip is really related probably to higher level students more than standard level students, but I think the examiners are going to want to test your mathematical skills. And by that, I don't mean the simple ones, sadly. I think they're going to look at things like exponential decay and how you turn them into a straight line graph and how you analyse those exponential decay relationships. And the key topic for that, I suppose, is in radioactive decay. So I would take some time to head to E3 radioactive decay, and I'd add in relevant graphs and relevant relationships on how those graphs might evolve when you look at the natural log and so on. I think examiners are going to be looking to test that skill most of all, particularly in paper 1B. And those are my 6 tips for annotating your own IB Physics data booklet. I think it's a really valuable exercise. It allows you to cover the majority of the IB Physics syllabus in a couple of hours, and you really are forced to think about the links between the topics and how you would use them in the exam. If you're interested in the concept of efficiency and IB Physics exams, I highly recommend you join me inside Tribe Physics. Tribe Physics is where I provide every single thing you need to get a 7 in IB Physics. There's concept videos, there's screencast past paper questions, there's mock exams, there's study timetables, there's exam technique. Everything that you need is there, and it's all led by my 20 plus years of experience eating, drinking, and breathing IB physics. It's tried and tested by thousands of students. I'm so happy to help so many people in this area, and I'd love for you to become a member. And of course, inside Trib Physics, you will get my annotated data booklet as part of the package. Okay, hope to see you there, and I hope you really enjoy I was going to say the journey, but it's not. I hope you enjoy the task of annotating your data booklet. All right, have a great day. Bye.